In the mid-2000s, Nvidia was famous for making games look gorgeous. Trailers got shinier, explosions bigger, lighting closer to magic. But gaming is a roller coaster. New consoles, new APIs, holiday cycles that make or break quarters. Inside the company, a different question started to echo. What if the same chip that draws dragons could also do math for the real world? At first it was hacker energy. Researchers and graphics wizards were abusing pixel shaders to run physics and finance code that had nothing to do with pictures. It worked if you were stubborn. You wrote code sideways, you debugged with a magnifying glass, and if a driver sneezed, your week was over. The spark was there. The missing piece was a way to make it boring in the best sense. Nvidia's answer was 3 syllables and a long attention span. CUDA. The idea was simple to say and hard to execute. Let normal C and C++ developers write code that runs on a GPU without learning a new religion. Make parallelism feel familiar. Hide the plumbing. If it worked, the GPU would stop being a card for frames and start being a coprocessor for everything. This was not a checkbox feature. It was a bet that the center of gravity in computing would shift from CPU first to accelerated. That meant pouring money into compilers, debuggers, profilers, documentation, and developer relations long before spreadsheets said it was worth it. Most companies sell hardware and toss in an SDK like a pamphlet. Nvidia did the opposite. Build a world where the hardware is just the beginning. The early wins were geeky and quiet. A lab sped up linear algebra. A university crunched protein folds in hours instead of days. A hedge desk ran a risk model before the market opened. None of it was flashy, but the pattern was clear. Take a problem that splits into many tiny jobs, feed it to thousands of GPU cores at once, and you get back time. Time to try a bigger model, add more data, or ask a better question. Then came an earthquake with a friendly name. Deep learning. All those multiply accumulates that made forests look real turned out to be perfect for training neural networks. Suddenly a camera wasn't just recording, it was recognizing. Accuracy curves bent up, training times bent down. Developers who had ignored GPUs started buying them on purpose. The moat wasn't just silicon, it was convenience. CUDA was a passport, but the journey needed roads. So Nvidia shipped libraries like Kublas and CUDA, examples you could copy, forums that answered at 2 a.m. and profiling tools that told you exactly why your kernel was slow. They didn't just sell speed, they sold the feeling that speed was attainable. That feeling turns experiments into habits and teams into ecosystems. The world stress-tested the bet. Crypto mining jolted demand, then vaporized it. For a minute it looked like the company was surfing hype again, but the AI line kept climbing, steadier, quieter, backed by budgets, not memes. Buyers changed from gamers and tinkerers to labs, startups, clouds, and giant enterprises. They all needed the same thing, acceleration they could trust, and the fastest on-ramp was already paved. Nvidia kept shipping the unglamorous pieces that compound. Faster interconnects so GPUs talk like a team, software that squeezes more from the same silicon, reference designs so clusters don't start from a blank page, cloud rentals so anyone can try it by the hour. When people say they sell GPUs, the better sentence is, they sell time to results. Competition arrived as it should. Smart chips, open tool chains, aggressive pricing. Some alternatives beat on paper. But switching an entire workflow is not a blog post. It's risk, retraining, deadlines, and 1,000 small incompatibilities that leak time. Teams that tried to leave discovered how many little conveniences they were taking for granted. The moat was partly physics and heavily accumulated UX. Zoom out, and the GPU that drew dragons now runs language models, designs proteins, helps robots see, and lets studios finish films on deadline. The through line is not magic. It's 1,000 engineering decisions that each save someone 10 minutes. Enough 10-minute wins and you get a decade. None of this was guaranteed. The company took reputational risk betting that developers would learn a new way to think. So, what are the building blocks that made the bet work? Start with parallel-friendly workloads. Linear algebra, image and signal processing, simulation, search, recommendation, transformers. If your problem can be split and recombined, the GPU smiles. Then layer software abstractions so a normal engineer can use that smile without a PhD. Then give them proof they won't be alone. Docs, samples, community, and someone to answer when it breaks. Developers don't adopt speed, they adopt certainty. If you're building today, you don't need to build a GPU to steal this playbook. Pick a shift you can explain in one sentence. Kill friction aggressively, especially for the people who extend your product. Ship enough of the stack that customers stop thinking in parts and start thinking in outcomes. Treat docs, examples, and support like core features. Today, Calling a GPU just for graphics feels like calling a phone just for calls. The same silicon that drew dragons now writes paragraphs, predicts protein shapes, and helps doctors spot what the eye might miss. So here's the invitation. If you're building an app, a tool, a company, pick your CUDA, your risky simplification that makes other people faster. Make it boring. Make it dependable. Keep sanding the edges until your ecosystem feels inevitable. By the time the world calls you lucky, you'll know the truth. You chose early and stayed stubborn.